Welcome to the Audio Architect Ambient Noise Compensation Overview video. Ambient noise compensation, often referred to as ANC, provides a hands-free approach to maintaining proper loudness in a fixed installation regardless of the present ambient noise. It automatically controls the gain of an announcement or background music according to the measured ambient noise through the use of a suitably placed microphone typically mounted in a ceiling or wall that is focused on the ambient source. SoundWeb London processors support two types of ANC, gap and non-gap. Consider a factory floor where paging announcements are made throughout the day. Employees are hard at work, possibly operating machinery, filling orders, or conversing with one another. All in all, there may not be anyone readily available to adjust the output volume during busier points of the day so that any important paging announcement is intelligible at an appropriate level. So what can we use? ANC Gap is a perfect choice for this type of paging announcement application, considering it will measure the ambience of the environment in between announcements. The ANC Gap object found in a SoundWeb London processor provides two inputs, the first for the announcement channel and another for the ambient measuring microphone. A mono output is provided for reinforcing the announcement channel. Opening this processing object reveals several controls for fine-tuning how the ANC works within a given space. An ambient level meter displays the current ambient noise level. Ambience that falls below the threshold control will result in no change to the announcement level. Ambience that exceeds the threshold control will result in the announcement gain being increased equal to the amount over the threshold. The further this control is reduced, then the more the announcement will be lifted out of the ambience. The minimum gain control determines the minimum amount of gain to be applied to the announcement and should be set during quiet ambient levels. A maximum gain control determines the maximum amount of gain to be applied to the announcement and is ideally set during high ambient levels so that a suitable announcement level is acquired. The speed control determines how quickly gain will be applied to the announcement channel. A gain meter indicates the current announcement channel gain. Gap controls such as the gap LED will indicate when an announcement is below the gap threshold, indicating that ambience can now be sampled and measured. The gap time determines how long the announcement channel must be below the gap threshold in order to begin measuring the ambience. While there are no hard numbers that can be provided to make this work in every environment, it should be mentioned that highly reverberant spaces may benefit from using a longer time setting as to avoid measuring any announcement reverb tails as ambience. Finally, a bypass button is available to remove the processor from the signal path. It's worth noting that if this is bypassed, the announcement gain meter is still operational so as to indicate how much gain will be applied to the announcement channel. Let's see this in action. We'll go online, and for this demonstration, a custom panel was created and it includes all ANC Gap controls. Pink noise is used to simulate both ambience and program audio, and we have level controls for each in addition to mutes. Metering has been made available for the announcement channel both pre and post ANC. Currently, the announcement channel is set to operate at 0 dB and is muted. Because it's muted, we can see that the ANC is able to measure the ambience and apply gain accordingly. Due to the ambience falling below the ambient threshold of -20 dB and the minimum gain set to -10, we can see that -10 dB of gain is being applied to the announcement channel. As we unmute the announcement channel to simulate an announcement being passed through, we can see that the output of the ANC is hovering around -10 dB. Any changes to the ambient level while making an announcement will not alter the applied gain of the ANC object. However, we can use the set buttons to override the applied gain of the ANC object in order to get the minimum and maximum values set for low-level and high-level ambient applications respectively. Muting the announcement, we'll see after 2 seconds that the ANC object can now start measuring ambience. As we increase the ambient noise past the threshold, we begin to see more gain being applied to the announcement channel. Reaching -10 dB on our ambient level, we now see +10 dB being added to the announcement channel. This is because we are allowing for a maximum of 10 dB to be added, and for every dB above the threshold, we are adding a dB of gain to the announcement channel. As we unmute the announcement channel, which is still currently set to 0 dB, then we can see at the output that this has been lifted by 10 dB. Now let's consider the other form of ANC, which is non-gap. This tends to be the preferable form of ANC for background music applications. Background music services often result in little to no gaps, and therefore do not allow for proper functionality from gap ANC. The same basic ideas of providing hands-free level adjustment apply to non-gap ANC, but instead of waiting for gaps in the program audio, the non-gap ANC is always measuring the ambience. Let's jump back into our venue file to see the ANC non-gap object at work. In a Soundweb London device, the block itself consists of the same two inputs and single output. Though we may be passing background music through this processor, we'll still refer to the first input as the announcement channel. Similar to the ANC Gap demo, let's bring up a custom control panel created for this ANC non-gap, and it will also allow us to easily view the meters and controls for the simulated background music and ambient noise. We find we have a slightly different set of controls for the ANC non-gap. We have the ambient meter and threshold, the channel gain meter, minimum and maximum gain controls, and a bypass that all function as they do in the ANC Gap. And that's where the similarities stop. A ratio control determines the amount of gain that will be applied to the announcement channel. So if the ambient level is 3 dB over the threshold and the ratio control is set to 1:1, then the amount of gain applied to the announcement channel will be equal to 3 dB. A ratio of 2:1 will result in 6 dB being applied to the background music channel, and a setting of 0.1 to 1 would then result in 0.3 dB. Attack and release controls are available for tracking the ambient level of an application. Shorter times are recommended for applications where it's wished to quickly adjust the announcement channel according to a sudden change in the ambience. As an example, it may be desired to quickly apply gain to the announcement channel on a railway platform as a train approaches in order to lift any background music and pre-recorded announcements. Longer attack and release times are preferable for gradually applying gain to the announcement channel as ambience builds up. A retail environment can benefit from these longer values as it fills out approaching peak shopping times in a day. As we can see, it doesn't matter that the announcement channel is active. We can make adjustments to the ambient channel to simulate changes in the ambient level, and the gain will be applied to the announcement channel accordingly. So how do we resolve this issue? Well, if we happen to be using a DSP featuring acoustic echo cancellation, such as the BSS Soundweb London Blue 101, which features 12 channels of AEC, then we can wire the microphone being used to detect ambience to an AEC channel. Then we can reference the background music post ANC non-gap to inform the ambient microphone that it should ignore the music as an ambient source. It would then be recommended to disable any noise cancellation by setting the NC level to 0, and start off with all other controls in their default state. It should also be noted that raising the nonlinear processing closer to 100% may result in degrading the true ambient noise as it passes through to the ANC object. In conclusion, let's take a moment to consider a few other helpful tips when using ANC. Depending on how sensitive the microphone is, its polar pattern, and how far away it is from the ambient source, the preamp gain for the ambient microphone may need to be adequately stepped up for proper operation of the ANC object. In order for the ANC object to be more efficient with background music, playback sources may need to be normalized using a leveler in order to have consistent level and to avoid applying gain to a low-level signal. Filters can be used on the ambient microphones to optimize the ANC object for a particular frequency range. In a large zone environment, a single microphone may not be adequate for capturing the ambience throughout the entire space. Several microphones can be mixed together to get an average of the levels before being wired into the ANC object. And finally, due to the ANC object possessing the capability to raise signal levels beyond the clipping point, take caution when setting the maximum gain values and use a limiter on the output to prevent any short-term high-level peaks from passing through the amplifier and onto the loudspeaker. This concludes our overview of ambient noise compensation. Thanks for watching.